Hello, everyone. Well, welcome to the Cryosphere Pavilion. Thank you to the ICSCI team for having us. So welcome to this side event that is organized by AMAP, the Arctic Monitoring and Assessment Program. And this event is on Arctic air pollution and climate change. So my name is Heidi Silvestre. I work at AMAP. I have the pleasure of working with Rolf Rudven, who will be the next speaker. And I'll be moderating this session. And I also would like to extend my thanks to my colleague, Simon Wilson, who has co-organized and co-developed this session with me. So we have a really great program in store for you today, starting with the introductory remarks from Rolf Rudven, who is the Secretary Executive of AMAP. That will be followed by a talk from Laurie Bruweiler, who is a physical scientist at NOAA, in the Earth System Research Laboratory. And after Laurie, we'll have the pleasure to welcome Shilpa Rao, who is a senior researcher at the Norwegian Institute for Public Health. And finally, we're very lucky to be joined online by Sean Pryor, who is a lead advisor at the Clean Arctic Alliance. Okay, so let's get started. We'll start with keynote presentations, and then we'll have a time for a Q&A for those of you in the room and watching online. If you have any questions, please don't hesitate to get them ready. So Rolf, I think whenever you're ready, I will stop sharing my screen here and we will share yours. And we're all ears for you. Thank you for joining us, Rolf.
Thank you, Heidi, and thank you so much for this nice introduction. And good morning, everyone. As Heidi said, my name is Rolf Rudven. I'm the Executive Secretary of the Arctic Monitoring Assessment Program. First and foremost, my apologies for not being present in person there. Unfortunately, didn't make it today, but I'll be there later this week. So I hope to meet some of you later this week. And please do not hesitate to reach out. I'm going to introduce these excellent role speakers following me by talking a bit about our work on impacts of shortening climate forces on Arctic climate, air quality, and human health. The subsequent speakers will talk more about topics when it comes to air pollution and climate change. I'll say a bit more about what the Arctic Monitoring Assessment Program does and how we do feed our results into policymaking, and I'll say a bit about the upcoming initiatives on the Norwegian Shareship. So thank you so much for inviting me, and please do not hesitate to ask questions afterwards. So first, to start up with, the Arctic Monitoring Assessment Program, or AMAP, as I will say from now on, not to twist my tongue, was established in 1991, actually as a direct effect of the opening of towards the east with Russia. And so it became a part of the Arctic Environmental Protection Strategy in 1991. It was organized as a working group to the Arctic Council from 1996, and we still are. And just as the Arctic Council, we do have delegates from all the 8 Arctic states, the 6 permanent participants, and that is our term for indigenous peoples organizations, observers, that is both government states and non-state observers. And also, I would like to emphasize that our assessment work is relying on our expert groups, and that consists of about 800 experts distributed worldwide, both from the Arctic states, but also from observers and organizations. And the AMAP Secretariat is located in Tromsø, although, as you see, we already have one of our colleagues down in Dubai. So, thanks. So what does AMAP do? Well, our mandate is to monitor levels and trends and assess the effects of anthropogenic pollutants in all compartments of the Arctic environment, as well as to assess effects of climate change on Arctic ecosystems. That also includes human health impacts, as well as effects of multiple stresses. So basically, we try to focus on the changes we see in the Arctic and how they affect the whole ecosystem and how they interact. So what we produce? Well, our main product is, and I'm going to talk more about one of these later, is assessment reports like this. Those are scientific assessments with peer review. This one is about 370 pages long. They are, of course, based upon our monitoring programs and guidelines. we do know that those reports are not read by policymakers, so we condense them down to like a 20-page summary for policymakers, which is more edible for those not working as scientists on an everyday basis. These acts as advice to the Arctic Council and to what's called senior Arctic officials, but more importantly, from our side, they act as to feed advice and data to international organs like the IPCC, the Stockholm Convention on persistent organic pollutants, the Minamata Convention on mercury, conventions we'll come back to, WHO and others. And on the lower row here, you can see some of our latest reports. Yeah. Just to start with, to remind ourselves, why is the Arctic so important? Well, it's of course important in itself, but it's also kind of a canary bird of the globe. So the Arctic is a sensitive indicator both for pollutants, where we see them being brought up by air and by sea. They've been accumulated and sometimes magnified through food webs, and they impact ecosystem health as well as human health. But also when it comes to climate change, we do see that the Arctic warms, well, 3 to 4 times as fast as the global average, and some places even faster than that. And it also has some of the fastest rates of ocean acidification. So it's really, literally speaking, a hotspot for climate change. And also what happens in the Arctic affects the rest of the world, for instance, through sea level rise or weather couplings. Yeah. 2021, we published these reports, the AMAP assessment reports on impacts of short-lived climate forces on Arctic climate, air quality, and human health. The assessments were led by Karl Kopien from Finland, Sabine Eckhart from Norway, and Mark Flanner from US, but we also had, in addition, 139 other contributors to the two reports. You can see the report on the left-hand side here, the scientific report, 370 pages of science, and you can see the summary on the right-hand side here, and they're both freely downloadable at our website, and you can assess them through the QR code below there. So, and some of the subsequent followers are going to present results from this. I'm just going to give like a very general introduction. So why are short-lived climate forces important? Well, first and foremost, they include greenhouse gases, particles, and air pollutants that strongly influence climate, but also they have relatively short lifetime compared to carbon dioxide. However, also by reducing emissions of short-lived climate forces, it's not only important for climate, but it also have importance for human health, including also wildlife health, as Shilpa will talk about later. In the report, we focused on these four short-lived climate forces: methane, ozone, sulfates, as well as black carbon. I would just like to emphasize that not all of these enhance Arctic warming, but for instance, sulfate to reduce climate warming, though it's very harmful to human health. So they have diverse effects. So how does this report feed into policymaking? Well, this slide shows the kind of the setup of the work processes. So on the left-hand side, you can see how the emissions data is being combined with observatory data on those different climate forces mentioned. These feed into computer simulations and model evaluation development. So we run both models for pollutant transport models as well as climate models. And these are tested and evaluated continuously. We feed also in emission inventories as well as emission scenarios to see what kind of outcome can we have from different legislations. And then the outcomes of this feed into here, in particular, three international processes: the Air Convention, where the air quality results and health impacts feed into the Air Convention. Health and climate feed into the Arctic Council, the policymaking through Arctic Council, but also the climate impacts feed into the conventional work on climate change, of which we are taking part in here today. I'm not going to say much about the findings, I will leave that for the subsequent speakers. However, I just want to show this to emphasize why we're actually doing this. The slide on the left here show black carbon, and the slide on the right-hand side has show methane emissions, the trends in methane emissions in Canada and on Svalbard. Please do not mind the legends, but I just want to use them to illustrate that policy or regulations through policy making works. As you can see on black carbon, there's been a significant reduction on black carbon emissions, which we also see on observations. However, when it comes to methane, we do see that the industrial development in the Arctic and flaring and so on has contributed to a significant increase in methane emissions in the air in the Arctic. Yeah. So just to say about what's going ahead of us for AMAP and Arctic Council. We do have a lot of focus on the effects of short-lived climate forces. One initiative that is in particular under in focus right now is wildfires. Wildfires contributes to about 12 to 15% of black carbon in the Arctic. And there's a wildland fires initiative through the Norwegian Chairship, which also AMAP is taking part in by, as you can see on the left-hand side, also by making scenarios on how climate change affects the trends in wildfires in the future. So that was all I was going to say for the introduction. I hope you will enjoy the subsequent speakers. For those of you interested in the work, please feel free to contact us or download our reports. And thank you so much.
Thank you so very much, Rolf, for this great introduction to this event. So now we're going to move to a recorded presentation by Laurie Bruweiler. It would have been 2 a.m. for her in order to join this side event. So I'm glad that we were allowed to use this option. And Laurie is basically a physical scientist at NOAA. She works for the Global Monitoring Service. And so I will need to share my slides again. So let me see, Amy. I can't remember if they're already shared. Give me one second. Screen. And there we are. So the slides should be available, Amy, if you see them. Perfect. Oh, I can't go back to PowerPoint. I'm using your trick to play the video. So there we go. at this COP28 event. So we'll now move on to, and we're very happy to have you here in person, to Shilpa Rao, who is a senior researcher at the Norwegian Institute for Public Health. And I will just move on to the next slide. So we find your slides, Shilpa. And here they are. Let me see. And there we go. So you can flick those slides just here. Okay. Thank you so very much. Thank you. Good afternoon, everyone. I'm Shilpa Rao, as Heidi said, and I worked with the AMAP report, and which is why I was invited here to present in this pavilion. Thank you, Heidi, for the invitation. Thank you to AMAP for inviting me. I'm very happy to be here in person. I will talk, I think some of my slides perhaps coincide with the previous presentation from Laurie, but my focus basically is on human health because I'm a senior researcher at the Norwegian Institute of Public Health. So I work mainly on public health. So I will talk a little bit about the AMAP project, but I will also mention a new project that a lot of the people from AMAP are involved in, which is called ABC ICAP. It's an EU-funded project, but we have a lot of partners from AMAP who are included there. So my results will kind of take the results that Laurie showed earlier in the AMAP report and take that further, giving you a very first view of some results from ABC ICAP. We'll just share the slides again, if you don't mind. Just so people online can see the slides as well. Yeah, exactly. Maybe it's not. Yeah. Yeah. Okay. Yeah. Yeah. Thank you. You can't change the size. Let me see. Oh yeah. Okay. What do I need to do? Yeah, nice one. I need to quickly look. Okay, sorry about that. So just to give you a brief introduction of short-lived climate pollutants and the impact they have on human health. As already mentioned earlier, short-lived climate pollutants are short-lived pollutants that are in the atmosphere for relatively shorter periods of time compared to greenhouse gases. But they have a lot of impact on, and they come from various sources in the Arctic. Flaring associated with oil and gas is a major source of these emissions. Diesel engines, shipping, use of fossil fuels, and wood for domestic heating are important local sources in the Arctic. But there's a lot of also, international shipping is nowadays discussed a lot for ships that pass through the Arctic regions. There are a lot of sources for these emissions in the Arctic. The two SLCFs that have been mentioned earlier by Laurie are BC and ozone. So BC and ozone have significant air pollution related health effects. As you can see on the left side, you can see that they produce impacts, particularly on cardiorespiratory health. And you have, at the moment, the figures vary a little bit, but you have about 7 million deaths that have been associated with PM 2.5 globally. And air pollution is considered the fifth leading global health risk factor and the leading environmental and occupational health risk factor in all Arctic Council members and observer countries. So it's important to look at these impacts. I think this has been discussed earlier by Rolf, but I will go through it again. The AMAP objectives are to investigate emissions of SLCPs in the Arctic region. And in particular, in this presentation, we talk about the investigation of these impacts on human health, associated costs, which is something new. We've been also working on the socioeconomic costs in the new project that we have, and looking and also looking at the climate benefits of these actions. And we also are looking at opportunities, something that was mentioned earlier, on how we can implement these scenarios. So you have methane, you have wildfires, various components, and AMAP is also making efforts to try to understand how these can be reduced in the future. These sources can be mitigated in the future. As mentioned earlier, I will talk about the two scenarios here, the CLE and the MFR scenarios, but I will present some updates. As you can see on the right side, these results are, of course, already talked about to some extent in the AMAP assessment report, but I will present relatively new work from the ABC ICAP project. And in the end, I will thank all my colleagues from that project who have contributed to this work.
And what we do here is we investigate two scenarios. These are from the World Energy Outlook, the IEA World Energy Outlook. One, we have the new policy scenario, and then we have the sustainable development scenario. So the new policy scenario, basically, the global CO2 emission pathway here can be compared to the SSP2 4.5. So basically a business as usual type of scenario. And then you have the sustainable development scenario, which I think can be very relevant in the COP here. It includes a huge reduction in fossil fuels, rapid phase out of fossil fuels. And the global CO2 emission pathway here can be compared to the SSP1 2.6 emission scenario. We assess the same policy packages that Laurie described earlier, the CLE and the MFR. So we have two scenarios which show the currently agreed climate and air quality legislations. And then we have a kind of dramatic scenario in some sense, which includes ambitious air quality targets, assuming full implementation of technically feasible SLCF emission reduction technologies, along with the SDS energy assumptions. So that's basically rapid phase out of fossil fuels plus rapid phase out of air pollution. So everything that you can do. And here on the right side, you can also see the figure that shows you that there's a large difference in the fossil fuel emissions of these scenarios. This figure didn't come out as well as I thought, but what you can see here is on the, you can see the CO2, CH4, the sulfur, BC, and the OC emissions. And this is from an article that we published recently, read by Knut van Salsen, who was the lead author for, one of the lead authors for this AMAP report. And you can see here that the CO2 emissions, on the top are correspond to the SSP scenarios. So the red, orange, yellow, and the green basically are the SSP scenarios. And then if you implement the CLE and MFR legislations and the MFR SDS legislations, as I explained earlier, you see in the dotted lines, you can see these huge decreases in all the emissions, basically. But you see that for methane, there's still, if you look at the CLE scenario, there's still an increase in methane emissions, whereas all the other pollutants more or less come down. So that's the description of these scenarios. Coming to the impacts, you can see here on top, you see the anthropogenic PM 2.5 emissions, and you can see again that there's a huge reduction in these emissions. And in the AMAP report, we discussed both the Arctic Council and the Arctic Observer countries. And you can see here that the MFR SDS, which I will stress for this presentation, has by far very low emissions also for the observer countries. And this leads to significant impacts on mortality. So the bottom slide shows the mortality across the scenarios. Perhaps easier to show this with the next slide, which basically shows you the mortality impacts across the different scenarios. And as you can see here, there is a huge reduction in the MFR SDS scenario in most countries of the world. So you can see in the US, in Russia, which we had considered for the AMAP report, in the Nordic countries, and in many other places of the world, you see this huge reduction. In some countries, you see, as mentioned earlier, there is a demographic assumption in these scenarios. Population grows by 25%. And you can see that because of these population assumptions, you see in some regions of the world, for example, India, and to some extent in China, you don't see the same kind of reductions that you see in other parts of the world, mainly because there is more aging population in these countries, which means more impacts in these countries. So that's important to keep in mind. As we face climate change, we also face more aging futures, and this could mean an additional impact for these kind of populations. This is actually done by a colleague, and I will by Pontus, Roldan Pontus, who is in the ABC ICAP project, and he is at the moment estimating the carbon dioxide equivalent emissions. And as mentioned earlier, I think methane has an important role. You can see that methane emissions are very significant here, and that they have an important role to play also in the future. But I will not spend much time on that. We are also in this new project, this ABC ICAP project, we're also calculating the socio-economic benefits. So what does it mean to reduce these emissions? What are the costs associated with reducing these emissions? And the blue lines here basically show you the net abatement cost to phase out fossil fuels, the net abatement cost for MFR. And you can see that the right side, the red and black bars dominate this figure. you can see that there's a huge impact. The economic value of changing PM and the economic value of changing climate impacts is significantly amplified in these figures. You have, of course, these impacts are uncertain. When you calculate socioeconomic impacts, you first calculate the health impacts, then you put a monetary value on these health impacts. So this is a significantly uncertain calculation. But these ranges show you that the benefits from reducing PM, or in our case, BC and black carbon and ozone, are significant in the MFR-STS scenario. I think this was mentioned earlier, and I promised to bring this up in this presentation. The ABC ICAP also is looking at wildfires. I don't have any results from the project as yet, but you can see that both our pollution scenarios, the CLE and MFR, do not consider wildfire emissions and reductions in wildfire emissions. And this can have a significant impact. As you can see, there's a huge peak in wildfire emissions recently. And in the future, I think reductions in wildfires, because a lot of them are started, as mentioned earlier, by human activity, and there needs to be also some effort, including these reductions in wildfire emissions. So to conclude, key messages that I have is strengthening air pollution legislations to the technically feasible level and phasing out fossil fuel use leads to a decrease in mortality by 35 to 50% in 2050 and a decline in morbidity by about 30 to 40% in the Arctic Council countries. Please keep in mind that some of these estimates are still rough and we are still, putting this together. I think we will release the report later on in next month or in January, so you can take a look at the report after it's released. The monetary related benefits currently are estimated at 250 to 750 billion euro in 2050, and these benefits likely exceed the costs associated with these actions. And efforts need to be made to improve understanding of future evolution and mitigation of wildfires and international shipping, which may contribute to increasing air pollution and health burdens and changing climate. In terms of policy, one of the things that my colleagues came up with is that EU should include black carbon in the EU emission trading system. I think this is something that my colleagues put together. And methane and N2O should also be included for other sectors than shipping, and also to promote other countries to introduce national emission trading systems. We also would like to stress that actions on reducing air pollution and fossil fuels will support the currently proposed European Green Deal, revision of the EU air quality legislations, and the setting of zero pollution objectives for air quality. So it's really imperative that both of these go together, not only for the Arctic regions, which we have investigated here, but for the world at large. Thank you very much.
Okay. Oh, perfect. That's important. Thank you so much, Shilpa. Thank you for being with us. And we'll now move on to the last speaker, who is kindly joining us remotely. So thank you so much, Sean Pryor. You are the lead advisor to the Clean Arctic Alliance. And we look forward to hearing your presentation. And I don't know if, Amy, you want to come here to share the screen. It's all good? Perfect. Thank you. Okay, perfect. We can see your slides, Sean. So you're absolutely good to go. Thank you.
Okay, thank you. I'm having problems. I can't move the slides for some reason.
Oh, can you click on your PowerPoint again?
Okay, yeah, got it. Okay. I don't know how to go back. Let's see if we can do that. Yeah, there we go. Thank you. And apologies for that. Thank you, first of all, to AMAP for inviting me to speak at this event today. And I'm sorry that I'm not there with you in person. I took a decision to not travel for a number of reasons, not just because of the climate impact, but for personal reasons as well. As Amy said, as Heidi said, I'm Sean Pryor with the Clean Arctic Alliance, which is a non-profit organization representing 21 groups that work collaboratively on the impact of shipping in the Arctic. It was formed around 7 years ago now, 7 to 8 years ago, originally to campaign on the use and carriage of heavy fuel oil, which is one of the dirtiest fuels in use today. and to campaign against the use in the Arctic because of the impacts of oil spills and black carbon emissions that have a climate impact. The coalition works on a range of campaigns now, focusing on the impact of shipping on the Arctic, with a particular emphasis on climate emissions, carbon dioxide, black carbon, methane, and NOx. Black carbon in particular because of the disproportionate impact that it has on the Arctic. But we also work on impacts on the oceans and the Arctic Ocean in particular from the use of scrubbers, which have been introduced to try and circumvent some of the regulations requiring use of cleaner fuels, or at least to find an alternative compliance method, but has resulted in pollution of the oceans. And increasingly working on other issues relating to shipping that have co-benefits. So underwater noise, where reductions in shipping speeds can introduce benefits both from an energy efficiency perspective and from the amount of noise that is being produced. Just a quick recap on black carbon. A lot's been said already, but that's what I'm going to focus on in this presentation. So I'm just going to quickly run over why we focus on black carbon. And as been said, it is a short-lived climate pollutant. It has an impact that is over 3,000 times that of carbon dioxide when looked at on a 50-year global warming potential basis. It contributes to warming while in the atmosphere, but it also accelerates melting when it's deposited onto snow and ice, which is why it has a disproportionate impact when it's released in the Arctic. The snow and ice leaves darker areas of land and water exposed, and then these absorb further heat from the sun, and so the reflective capacity of the planet's polar ice caps is severely reduced. These polar systems leads to increased melting, and this is what is known as the loss of the albedo effect. Black carbon also has a negative impact, as we've heard, on human health, and a significant impact on indigenous health, livelihoods, and culture. But what's not so well known is the amount of black carbon that is being emitted by ships. And black carbon makes up around 1/5 of international shipping's climate impact. And that's why we focus so much on shipping emissions. As has already been mentioned, there are many sources of black carbon in the Arctic or impacting the Arctic. I won't go through all of them since a number of the speakers have already touched on some of them. Wildfires and open burning contribute some of the biggest sources of black carbon currently. And the Arctic Council's expert group on black carbon and methane estimates that shipping accounts for only around 5% of the black carbon emissions in the Arctic. However, it's because of the proximity of ships to the snow and ice that it's having a disproportionate impact. North of 80 degrees north, shipping is the biggest source of black carbon. There's very other little activity north of 80 degrees north. But even north of 70 degrees north, shipping is still a major source of black carbon emissions. 2017, I was trying to work out how long ago that is now, I think sort of 6-7 years, the Arctic Council adopted what was considered then to be an ambitious target of a 25 to 33% reduction in black carbon emissions based on the 2013 levels. And the aim was to try and achieve this, or was to achieve this by 2025. The latest work published at the Reykjavik Ministerial in 2021, so just over 2 years ago now, shows that Arctic states are making good progress towards this target and reducing the emissions, and that it is likely that the target will be achieved in 2025. However, despite Arctic states being en route to achieve the reductions, it's not the case in every sector. And emissions from some sectors, notably wood, wildfires and shipping, have been increasing. Shipping is responsible for a range of atmospheric pollutants, not just black carbon. Other ones include SOx and NOx, and the impacts we've already heard about from SOx, which is actually a coolant, but NOx is warming impact. and then also carbon dioxide and methane, depending on the types of fuel being used. As some ships now are turning to alternatives, base fuel, gas fuels, but unfortunately the amount of methane slippage associated with gas fuels means that they're actually not much better in terms of climate impact. I'd like to just thank the International Council on Clean Transportation for the slides of theirs. So I'm going to use this slide and the next slide. They have been doing a lot of work on emissions of black carbon from ships specifically. And the work here shows that over the measurements over 4 years, so from 2015 to 2021, sorry, over 8 years, from 2015 to 2021, actually, sorry, over 6 years, but 4 lots of measurements, that black carbon emissions are increasing. And the first group of bar charts shows black carbon emissions from heavy fuel oil use. And the second group shows black carbon emissions from all fuels. And what they have found is that over this 6-year period, there has been a steady increase in the amount of black carbon being emitted by ships. And they've also looked at the whole of the Arctic. The previous figures actually just focused on what is known as the IMO Arctic waters as designated under the Polar Code, which is shown by this blue line on this slide. But when you look at the whole Arctic, you'll see that actually the amount of emissions is even higher. And when we look at what we call the geographic Arctic, which is roughly 60 degrees north, we see that there are over 8,500 vessels emitting around 1.5 kilotons of black carbon. This is compared to a much smaller number of vessels in what's known as Arctic waters, only 1,866 vessels, and only 413 tons of black carbon. So what this means, what this shows is that across the whole of the Arctic, that the black carbon emissions are coming from particular areas, but also that we need to take action across the whole Arctic and not just in certain areas. I mentioned earlier that, sorry, I've said that already. I'll move on. There are a number of options for solutions, and frustratingly, when it comes to shipping, some of these options are actually quite simple and have been on the table for some time. At the International Maritime Organization, which is the UN body, the UN agency that is responsible for regulating international shipping, black carbon emissions from ships have been on the agenda for over a decade now. And at the moment, they currently remain completely unregulated. There are a number of possible options. As I say, some have been on the table from the very beginning of those discussions. I'm just going to run through the different options quickly. The first option, and probably the simplest and easiest to achieve, would be simply to switch to distillate or alternative clean and non-fossil fuels. Frustratingly, I find this very frustrating because actually this is talking about moving ships from a very polluting heavy oil-based fuel to diesel. Diesel is the sort of fuel that we're trying to move away from in terrestrial systems because of how polluting it is. But in shipping, we're using, or ships are still using much dirtier fuels, and we're allowed to do that. Moving to distillate fuel would see reductions of between 50 and 80% in black carbon emissions. And it depends, the variation is, it depends very much on the type of engine, the load of the ship, the speed being operated at, etc. But we would see significant reductions. Other measures or other options include the development of an Arctic aromatic fuel standard. We know that the amount of black carbon being emitted from burning of fuels can be related to the amount of aromatics in the fuel. And to measure that, we can look at the hydrogen and carbon ratio to get a good understanding of the amount of aromatics in the fuel. So what we'd like to see now is a fuel standard developed for polar regions that limits the amount of carbon that's going to be emitted when it's burnt. A solution would be to identify areas that countries could designate as areas in a particular risk, control areas. At the moment, this type of a regulation exists for the purposes of restricting SOx and NOx emissions, but not for black carbon. And if we were to introduce this sort of a regulation, then countries could decide to introduce stricter regulations in their own waters. And then fourthly, the installation of diesel particulate filters or other types of black carbon reduction technologies. Again, widely used on land already, but not used by shipping very much at all. There are a few ships now beginning to install filters to reduce the amount of black carbon emissions, but very, very few. Unfortunately, or the difficulty with particulate filters, though, is that you would have to employ one of the other measures first. You would have to move to somewhat cleaner fuels to be able to use diesel particulate filters. They can't be very heavy oil-based fuels. The IPCC sixth assessment report called for rapid, deep, sustained mitigation and accelerated implementation of adaptation actions this decade. And this is what we need to do when it comes to black carbon. We need to take action this decade if we're going to have the impact that's required. So I'm just going to spend the last part of this presentation looking at what can be done. So policy requirements, really, or policy steps. In terms of global and regional approaches, as I've mentioned, the International Maritime Organization is the UN agency responsible for regulating shipping, international shipping. And ideally, this would be the best place for there to be global regulation of black carbon emissions from ships. But there are other things that need to be done as well. Ideally, the Arctic Council should set a new target for black carbon reductions. As I said, it looks likely that they will achieve the target that they set themselves a few years ago in 2025. So ideally, it'd be nice to have another ambitious target set from 2025 onwards, and possibly specifically a target for shipping. So shipping at the moment is one of the areas that is still increasing its emissions of black carbon. I think there's work that can be done under other bodies as well. LURTAP, the Air Pollution Convention, is producing shipping guidance this month, and I think there's more that could be done that would be helpful there. And as Shilpa's just mentioned, European Union regulation would be very effective too, and commitments under other frameworks such as the Nordic Council. And then domestically, there's a lot that countries can do at a domestic level that would be valuable. There is already a heavy fuel oil ban that is due to come into effect next year. It won't be, there's a phased approach to its implementation, so it won't be fully effective until 2029. And so on its own, it's not going to be enough, but we do need countries to make sure that they implement it fully as quickly as possible. They could ban the use of scrubbers and scrubber discharges in their own waters. This would limit the amount of air pollution being turned into an ocean pollution problem. And as I've said, if we can get the right regulations in place, they could designate emission control areas. They can already do this for SOx and NOx emissions. And we know that some of the Arctic countries, Canada in particular, are looking to do this in the coming year. But we would like to see efforts made to actually be able to reduce black carbon, designate black carbon emission control areas to reduce black carbon emissions. And they could help with incentivizing best practices by shipping companies. And then in terms of what the shipping sector itself can do, it obviously can make choices. There is already an IMO resolution, which is recommendatory. So it has no legal teeth, but it urges ships to move non-fossil fuels. We would urge shipping not to move to liquefied natural gases as fuels because of the methane emissions. We would urge them also to start using, where they've moved to cleaner fuels, to start installing and using diesel particulate filters that will then effectively reduce black carbon emissions by over 90%. And also other measures like energy efficiency. By using slow steaming, as I mentioned earlier, there can be gains both in terms of energy efficiency and in terms of the amount of underwater noise generated. And increasingly, we think ships should be looking to wind-assisted propulsion, which will actually improve not only black carbon emissions, but CO2 emissions as well. Wow, busy slide. But that's it. Thank you. And thank you for this opportunity to talk today.
Thank you so much, Sean, for this pretty staggering presentation. I'm sure we all learned a lot in the room today. So thank you again so much for your time today. And we have now a moment to answer any questions that we may have received online and any questions we have from the room here. And I'm happy to say you can see them on the screen here, but Rolf is still here, of course, Sean, and we also have Shilpa, who is still with us. So do we have any questions from the room? And if you have a question, please introduce yourself and speak loud so our remote speakers can hear you. Shilpa, you'd like to ask a question? Yeah? If you can actually come to the stage, yeah, please.
I just have a clarification question for Sean, just to ask. I'm still confused. What is your share of BC-related shipping emissions in the Arctic? I mean, are you looking at from the Arctic regions or in general, the international? Because we are trying to do some analysis, also looking at shipping and looking at its impact specifically on human health. And our problem at the moment is that the share is very low from shipping. So I don't know how you calculate these shares of BC, but for us, this has proved a problem that the smaller shares mean that it's difficult to isolate the health effect just from shipping. So I'd like your comments on this.
Yeah, I can imagine that would be very difficult. The expert group on black carbon and methane has estimated that shipping share is around 5%, so it is small compared to some of the other sectors. But because shipping is operating in the Arctic and right up in the north, near to the snow and ice, the amount of black carbon settling out of the atmosphere once it's emitted into the atmosphere is high. There's a higher chance that it's going to settle onto snow and ice. I'm afraid I'm not aware of work that's tried to distinguish what black carbon is coming from ships versus what is coming from other sectors. But knowing that it only remains in the atmosphere for a matter of days to weeks, it is certain that the impact from shipping, which is operating in the Arctic, particularly up in the high Arctic, is having a bigger impact than perhaps some of the sources coming from further south. I think AMAP has done quite a bit of work on this in the past, and I have seen some work or reports by them that indicate that emissions from north of 60 degrees north have a greater impact than emissions from further south. And obviously we're talking about the shipping that is operating north of 60 degrees north. I'm sorry, that doesn't exactly answer your question, and I don't know that there is an answer, a precise answer anyway.
Great. I wonder if Rolf here, you have a comments about shipping and AMAP work. Thank you.
Thank you, Adrian. I can't supply you with the exact answer either, because I guess there is no exact answer, and the reason for that is, as mentioned by Sian here, Sian, is that it's very much dependent on the distance and also how it's emitted. I mean, we do see black carbon from wildfires being transported for long distances, but black carbon from shipping has a completely different pattern when it comes to being sent up in the air and being brought forward by the hot air and so on. So it's no exact answer, but it's correct as Simon says. The impact per unit is much higher for black carbon emitted locally compared to regionally, and I guess your estimation of latitude as Sean is quite correct. However, there's a lot of variation around this, and it's actually, I would say, this is one of the big uncertainties when it comes to global warming in the Arctic due to the Arctic amplification and the loss of albedo, for instance, with black carbon, or the reduction of albedo with black carbon. So thanks.
Thank you very much. Thank you both. Do you have any questions, other questions from the room on these topics? Do we have any comments online, Amy? No? Nothing? Okay. Good. Well, I think this is the end of this event, but thank you all again so much for attending in the room today. Thank you to everyone participating online. And of course, thanks a lot to our speakers for joining us on a Sunday. with crazy time differences. So we really, really appreciate it. And this video will be put back online with even better sound quality and subtitles. So watch this space on the ICCI YouTube channel and also on the AMAP channels. I'm sure we'll find ways to keep sharing this great material. Thank you all again so much. Have a good day. Bye-bye.
Thank you. Bye.
Thank you.